GCSE Physics Boosters, electrical power. That's what this video is about, electrical power. Let's do it. Now, electrical devices transfer electrical energy into other forms. In other words, electrical energy goes in, another type of energy comes out. Looking at these pictures, I'm sure you can figure out what kind of energy it is transferred into. So the kettle is obviously going to be heat. The lamp will be heat and light, more heat than light. This amplifier will be sound, and the fan will be kinetic energy. The motor in it will transfer electrical energy into kinetic energy. So electrical devices transfer electrical energy. Now, how much electrical energy a device will transfer depends on two things. The first one should be obvious, is how long it's switched on for. If it's switched on for twice as long, it'll transfer twice as much energy, which is why your mum has a go at you if you leave your bedroom lights on. The second thing is the power of the device. Here are some different kinds of light. We'll start with some LEDs. Now, an LED has a power of about 0.07 watts. The bulb in this torch is about 3 watts. This bedside lamp, that bulb is about 30 watts. Street light is about 200 watts. And then this big Super Trooper in the theatre, big spotlight, 1.5 kilowatts. Notice that the power is getting bigger and bigger as they get brighter and brighter. They are transferring more and more energy, and that's what the power tells us. So this electrical device transfers electrical energy into heat, the kettle. Now the power is how much energy it transfers every second, i.e. the rate of energy transfer. Remember, the rate of is like divided by time per second. So power is energy transferred divided by time. Power is measured in watts, capital W. Energy transferred is joules, capital J. Time is seconds, little s. Power is energy divided by time. Energy transferred divided by time. You might have to rearrange this equation to calculate the energy transferred. That would be power times time to work out the energy transferred. Here's a couple of examples. What I suggest you do is pause the video. You've got your pen, paper and calculator. Work these out for yourself. I'll show you my answers in 3, 2, 1. Okay, so for each one, you write down the equation, rearrange it if you need to, bung in the numbers, work it out. Don't forget the units. So the first one, power is energy over time, 336,000 divided by 80, because the time has to be in seconds, and that gives 4,200 watts, or 4.2 kilowatts. The lamp, we want to work out the energy, so energy is power times time. 40 times 1 is 40 joules in 1 second. In 2 hours, the time will be 2 times 60 times 60, so 288,000 joules, or 288 kilojoules. Here's another equation that you need to know, which you need to learn, and it's energy transferred is Q times V. Q is the charge which flows through the device, and V is the voltage across the device. You might remember in the video about voltage, voltage is joules per coulomb. It's the amount of energy which each coulomb has, and this is the same equation, just rearranged. So energy transferred is QV, E equals QV. Here's a question again to have a go at. In part A, we're working out Q, and then in the second bit, we're working out the energy transferred. So if you want to pause the video, have a go at it. I'll show you my answer in 3, 2, 1. Okay, so there you go. Q equals IT. So there's your charge, 450 coulombs, and then E equals QV is 450 times 12 is 5,400 joules. Lots of equations in this video. In fact, here's a couple more. And all of these equations you need to learn. It's worth making an effort to learn your equations. I suggest all the equations you need to learn, write them down neatly, stick it on your bedroom wall. Okay, make an effort to learn them. Do some flashcards. Flashcards are brilliant for learning stuff like this. We've got power is energy transferred over time. We've got P equals VI, voltage times current, and we've got P equals I squared R. If you want to work out the power, which equation are you going to use? Well, you really need to know your equations, and basically you look at the information that you're given. If you're told the voltage and the current, then you'll use P equals VI. If you're told the current and the resistance, then you'll use P equals I squared R. It might be that you're told P and V, and you have to work out I, in which case you would have to rearrange the equation. Let's do some examples. Good idea. Okay, so lots of sums to do here. I suggest you pause the video, pen, pencil, calculator, get to work on these. I'm going to show you my answer in 3, 2, 1, go. Okay, first one pretty straightforward. You're told the current and the voltage, so P equals IV. The second one, you're told the power and the voltage, and we want to work out the current, so I equals P over V. The next one, we're told the current and the resistance, so I would say P equals I squared R. The next one, we're told the resistance and the current, so again, P equals I squared R. And then the last one, we're told the power and the current. So if P is I squared R, then R will be P over I squared, 2.2 ohms. There you go. Practice, practice. Practice makes progress. Practice doesn't make perfect. Practice makes progress.